Hey everyone, so here we'll be solving yet another problem on binary search, which is your nth magical number. As you can see, this is a hard problem on Leetcode, and like according to stats, if you go, its accuracy is less than 30% right now when I'm recording this video. So it is considered to be you can consider to be one of the hardest Leetcode binary search problem. Now let's see how can Mayank Bhaiya help you and simplify you. And guys, trust me, it will be a cakewalk problem for you. Okay, now let's see what this says. So you will be given three values, n, a and b. N, a and b. You have to find nth magical number for a or b. Okay, sorry, a and b, not a or b. Nth magical number for a and b. Now what is magical number? In the number line, in the positive number line, all the values who are divisible by either a or b, they are your magical numbers. And in that sense, you have to find the nth magical number. Let's say here you have to find fifth magical number. You have to find fifth magical number. Okay, so in brute force, because brute force is supposed to be the worst possible solution that you can think, so I started from 1. This number line, I started from 1 till where I'm going, I'll discuss later, no problem. Let's keep that upper bound where I can go to later, like what highest index. But at least I know as of now that for brute force I can start with 1. So I'll keep a count variable, which is obviously starting with 0. I'll see starting from 1, incrementing by 1 only, 1 2 3. So I'll see what numbers are divisible by either a or b, and I'll increase this count for them. So 2 is divisible, 1 is not divisible, 2 is divisible, increase the count by 1. 3 is not, 4 is divisible, increase the count by 2. 5 is not, 6 is divisible. Divisible by what? Either a or b, either 2 or 4. So 3. 7 is not divisible by anyone. 8 is divisible by 2 and both by 2 and 4, but and that we have to increase the count by 4. Okay, 9 is not divisible. 10 is divisible by whom? 2 or 4. Okay, right now it is divisible by only 2, but it is divisible anyhow. So 5, you got your 5 here. Okay, now what you have to do, as soon as you count, like your count is 5, which means you got your fifth magical number. You got your what? Fifth magical number. This is your answer. This is your answer. Okay, this is your answer. So here if you see guys, what you can see here. So in brute force, what we can do, loop from I equals to 1 to some value, some higher value. We'll discuss that later, no problem, be with me. And what you have to do, if your number, if your that I value is modulo a, like it divides by a and remainder is 0, which means it is fully divisible by a or b, you'll increase the count. And finally, after this if condition, check this. If your count is equals to n, return I. Okay, so obviously this was a brute force, and what you were doing, guys, if you see what you were doing, you were doing a linear search on top of what? A shorted space. Getting it, guys? This is actually a shorted space. This is your shorted space. So you're doing a linear search on top of what? Shorted space. So what you can go for next? You can go for binary search, obviously, because binary search is built on top of what? Linear search plus shorted space. Binary search is built on top of linear search plus shorted space. Look, here you're searching. You're not just linearly there's a difference between traversing and searching. You are searching for particular element. Obviously, you're searching for particular element. That is why linear search, like I am saying the word linear search, you're searching for some element. Okay, and if you're searching for some element in a shorted space, and if you're going in linear fashion one after another, you are dumb. You have to go for binary search, yeah, because binary search is built on top of what? Linear search on sorted space. So let's see, for an example, for that example, a or b, how I can, a and b and n, whatever we took earlier, how can I optimize this? Because right now you got that I have to go for, like, we have to go for binary search. Okay, don't ask me how to build the foundation for binary search. Binary search is built on what? If you go and watch my part 1 video, okay, if you go and watch my part 1 video, I've built that binary search on top of what? Linear search plus sorted space. Okay, so let's keep L here right now. H as here, like H as 15. I'll come. How can you find L and H to optimize your binary search? But let's keep it right now. So as you know, in binary search, what I did till now, but what I taught you till now, that once you got your like space, sorted space, so you have to divide that into two parts. One would be favorable, one would be unfavorable. Okay, and mostly what we did, because you can do anything, you can call it A or B, you can call it favorable, unfavorable, whatever the range you can. And what I do then, try to keep favorable zone at that zone as that zone where your answer may lie. Where your answer may lie. Sorry, not may, where your answer will lie. And unfavorable as what zone? Where you're sure that yeah, I'll not be getting my answer. So let's see. How can I calculate favorable and unfavorable for that? Okay. So before even that, so what I'll say, for every number, because obviously for LNH you'll be calculating mid. What we do in binary search, we calculate mid. So for every mid, for that matter, let's say I calculate mid as 12, somewhere like some iteration of LNH. While calculating mid, I got this 12. I got this 12. Okay, I got this 12. Now I'll calculate what x value for it. What do you mean by x value? X value is your which multiple, or I can say which magical number or which multiple it is supposed to be. If you consider this number line, which multiple it is supposed to be, this 12. So if it is coming, if it x is coming as greater than or equals to n, if it is your fifth magical number, if it is fifth magical number in on this number line, so onwards to fifth magical number, like including that magic, including the fifth magical number and all its right, I will call them favorable. As of now, I will call them favorable. So what I said, once you got your fifth magical number, nth magical number, so let's say here you are having 10 as your fifth magical number, onwards, like including this 10 onwards to right, I'll call everything favorable, and to its left, I'll call everything unfavorable. So here, let's say 9 was also, hey, 9 I missed, no problem, I'll include it right now. 9 is also your unfavorable. Okay, 9 is also your unfavorable. So all these will be like, now what we did, guys, I divided them in favorable and unfavorable. Look, as I did earlier, and as I told in part 1 as well, that this is not what you are supposed to like write in array. This is what, once you think, your answer becomes easy for you, because this do the two for spaces, they are depicted by what? They are depicted by your if and else that you write in the while loop inside binary search. So this will automatically be divided. Your search space will automatically be divided by what? If and else that you do in binary, that you do in while loop in binary search. It's just that you have to think of like where if your if and else, like when you'll go to if, when you'll go to else. That is what we do earlier, even before starting our binary search. Okay, then it becomes easier for you. Now if you see, guys, what this what like in these search spaces, unfavorable and favorable, obviously our favorable is in this favorable zone, but who will be giving your favorable? Who will be giving your answer in this favorable zone? Obviously the first value of your favorable, the first value in this favorable zone. Now see, guys, once your binary search is terminated, as we saw in tons of problems, we know that we won't keep track of any other variable. It's just LNH, they'll give your answer. Most of the time, LNH will give you answer. So who will give this time? L or H? As you saw in previous examples and in part 2 as well, I explained this beautifully. Your L will be, when your loop is terminated, finally, your L will point where? First value of the second zone, second space. And this is second space, correct? This is first unfavorable space. Look, unfavorable space is your first space, favorable space is your second space. So L will point where? The first space, the first element of second space. Okay, why? Because even in part 2 I've explained this, but if I can give you a quick revision of that. So L can travel all unfavorables, because L started on unfavorable. So the last unfavorable that it can travel is this one, and then it will cross the boundary directly. And once it reaches any of the favorable, obviously it can reach here, it will reach at the end here. It will not, because L was only supposed to travel when it was on unfavorable. In binary search, as you can go back on my part 2 video, it will be more clear for you, because I can't just waste like more time here, as I already explained that in part 2. So L will point where? L will point to your first element of second space, and H will point where? H will point at last element of first space. So obviously, who will give you answer? What do you want? First element of last space. So L will give you answer. Now you are clear that once your binary search is terminated, who will give you answer? Return L. That is the only statement that you have to write. Return L. That's it. Okay. And you also got how to calculate unfavorable and favorable. So you know that x greater than equals to n, like when you calculate this x value, which is the multiple, what we are calculating, which multiple is it? Okay, so once you are getting fifth multiple onwards, so if you are getting 6th, 7th, 8th, 9th multiple, they all will be your favorables. And if you are getting x less than n, which means less than 5 multiple, less than fifth multiple, 4, 3, 2, 1, 0, all these will be your unfavorable. Okay, all these will be your unfavorable. And who will be giving your answer? L will be giving your answer. But guys, let's see how will we calculate this x. We got L idea that we have to go for L, like we'll return L, but how will calculate this x? So what this x mean? What this x mean to you? This means which multiple is it? Starting from 1, which multiple is it? Okay, from left to right, which multiple is it? And guys, if you think of this, that only B, A and B, 2 and 4, they are contributing to multiples. Only they are contributing to multiples, because obviously for 2 and 4 we are checking for like whose multiple, like what multiple number can they be. So let's let's calculate what this 10, like which multiple is this 10 supposed to be. So obviously this 10 would either be contributed like by A till now. If you see the 10 multiple, so if you see the 10 value, so all the values who are divisible by A till 10, if you see all the values who are divisible by A, they will be coming, and all the values divisible by B will be coming. Now let's see how many values divisible by 2 from starting to 10. From starting, like let's say here 1, from starting to this 10 value, how many divisible, how many multiples of 10 you are getting, how many multiples of 2, sorry, you are getting till 10 value. So obviously 10 by 2, which is 5, so you are getting 5 multiples of 10, 5 multiples of 2 till 10. And all the like multiples, so they starting from this, they will be your left, not right. Okay, because we have calculated till 10. And till 1 to 10, how many multiples of 4 you are getting? So obviously 10 by 4, sorry, which is 2. So right now what you got here, you got 5 plus 2, which is 7. So actually this 10 is supposed to be the seventh multiple, but what we are seeing here, there is something new. It is fifth. You are saying it is fifth multiple, but why is it? It is because, as I said, 10 upon 2, here you are calculating what multiple, how many multiples 2 is contributing. But guys, there are two numbers, 4 and 8, who are contributed by 2 as well, who are contributed by 4 as well. Okay, so when you say that till 10, 4 is contributing its 2 multiples, so who are they? 4 and 8. And till 10, who 2 is contributing how many multiples? 5. And in 5 you are again counting 4 and 8, so even you are counting 4 and 8 twice, because but you have to keep it unique, you have to count only one. So you can see what 4 and 8 are actually. 4 and 8 are the LCMs of 2 4, because the LCM, all the numbers who are divisible by LCM. Okay, so let's say 4 is LCM, all the numbers who are divisible by LCM, they will be divisible by 2 and 4. Okay, let's see for 3 and 5, the LCM is 15. So all the numbers who are divisible by LCM, let's say 30, if 30 is divisible by 15, so 30 will be divisible by 3 as well, and 30 will be divisible by 5 as well. Okay, so that is what here we are seeing, that this LCM thing is making some some problem. Okay, why? Because this value, the value who is multiple of LCM, is counted by A's multiple, is counted by B's multiple, and that multiple number what you calculated in 5 and 2. So what you have to do now? So because they were counted twice, so we have to reduce their one occurrences. Okay, because 4 and 8 was counted in 5 as well, and 4 and 8 was counted in 2 as well. So what I have to do, we will see how many multiples are contributed by LCM, which is 4, 10 upon 4. So 4 is LCM, so 10 upon 4, which is now 2. So total you are seeing that from starting to ending, from starting to 10, total 2 multiples your LCM is contributing. So you have to remove one occurrences of each. So we have to remove 2. So 5 plus 2 minus 2, which is 5. So now you got the idea that 10 is actually your fifth multiple. 10 is actually your fifth multiple. So I hope in this way you will calculate your x value. Okay, let me write the formula for it here, and it will be easier for you. Okay, so how will you calculate x? X will be your mid divided by A plus mid divided by B minus mid divided by LCM of A comma B. Okay, LCM of A comma B. And guys, how would you calculate LCM? There are obviously this is not in this scope how to tell how to calculate LCM, but if I can say you, give you idea, simple mathematics, because these are elementary things that you have to at least have idea about before, when you start coding. So LCM into HCF, even HCF you call it as GCD, greatest common divisor or highest common factor. It is equals to what? Your A cross B. It is equal to your A cross B. And for GCD, you have lots of videos. It will take hardly 3 to 4 minutes. Or even there are functions. There are functions in many languages that directly give you the GCD value. Okay, we'll use one of its functions. In C language, sorry, in C++, we have GCD function. So we'll directly use that because it will only take 2 to 3 minutes to calculate what is GCD of A and B. So LCM is what? A into B upon GCD of A comma B. The GCD it is actually HCF, but here in programming we call HCF as GCD. So LCM, you know how to calculate LCM. LCM, you got the idea. So you got how to calculate X. Inside that there was something LCM, and you also got how to calculate LCM. You know you have to return L. Now guys, how, like, where would you keep L and H? L and H, where would you keep? Because in binary search you can keep as large as possible, no problem, but it will increase the search complexity of a time complexity. So where would your L and H will be? So I say L will be at where? The minimum of A and B, because that is supposed to be your first multiple. Okay, so minimum of A comma B is your first multiple. Okay, but what about H? So guys, if you see what the multiples of A and B, what you wanted, the fifth multiple of A and B. Obviously it is started, if you pay attention to the minimum of A and B, let's say here A is minimum. Okay, so if you see what we wanted, the nth multiple of A and B combined, the nth multiple. And if you pay attention to nth multiple of the minimum one, so either, if you see, let's calculate the nth multiple of A, the fourth, which is the first multiple. So this is your first multiple of A, second multiple, third multiple, fourth multiple, and this is your 10, which is fifth multiple. Okay, so if you see till fifth multiple, attention, pay your attention guys here, now let us see the multiples of this 4, which is actually greater than A. So we have calculated the multiple of minimum value. So now let's see the multiple of maximum value, which is, let's say, 4. So obviously either its multiple are here inside the first 5 multiples of A, or its multiple will be at some other zone. So these multiples of B can actually be some other numbers as well, so they can expand this range, like, so they can be in between this, the first 5 multiples of the what, first 5 multiples of, if you calculated a smaller value, so multiple of B is either, like, few multiples can be in between them, or they can be outside them. So at max, but what you are concerned with, the nth multiple of A and B combined. Okay, now here you are saying that the nth multiple of A and B combined, it can never go beyond nth multiple of the smaller value. Okay, because you wanted the, even if you can write it down on a pen and paper, you will get this idea that your H value, the maximum where you can even search for your calculating your nth multiple, it will be the nth multiple of what? Minimum of A and B. Why? Because we know we have to calculate the nth, because starting from, because you are going in sorted order, it's lower to higher. Okay, so you have to calculate the nth multiple, first multiple, second multiple, you have to calculate the nth multiple of A and B combined, and it can never go beyond nth multiple of the smaller value. Okay, it can never go beyond nth multiple of a smaller value. And why it cannot go? As we saw here, that we wanted the smallest fourth multiple, and obviously if the largest values multiples are in between, then also you see the answer can never go beyond the smallest values and the multiple. Okay, so we got the H value, we got the L value. Now see let's see the solution. So L and H we got, and we calculated the LCM, and then the simple cakewalk. So x greater than equals to n, which is your favorable zone. And guys, if you are at favorable zone, where would you move? If your mid is at favorable zone, where would you move? Obviously you will not go to right, you'll go to left, because you wanted what? First favorable. And if you're at unfavorable, where would you move? Not to left, you'll move to right. Okay, so how would you move to left? Sorry, how will you move to left? You'll push H to left, which is at mid -1. How will you move to right? You'll push L to right. Okay, mid +1. You can see this example. You'll push L to right. Okay, and return L. So guys, this was my answer. I hope you enjoyed this.